Hey everyone, in this video I will be deriving the expression for the center of mass of a rigid rod as determined by or from the center of mass at the very center. So this is a uniform mass distribution, which means that the mass is distributed evenly throughout. The mass density is known as the Greek letter lambda. We can write that, let's do it over here, lambda equals mass per length. Okay, it's of total length, capital L. And so in this case, this is a continuous mass distribution. So the moment of inertia can be written as integral r squared dm, right? Where again, the dm is for the differential mass. And so let's choose that bit of mass right there, and that is a distance from the center of mass we can call dx. Okay, so our lambda I'm going to rearrange actually and have mass solved for, which is lambda times L. But since we are differentiating in the x direction, I'm going to change that actually to lambda x. Thus, dm is equal to lambda dx. Now taking dm and plugging that into our integral, we have integral r squared lambda dx. Rearranging, pulling out the constant lambda, we have, I need to change that r, which is a placeholder for a distance in this case. In this case, we are integrating in the x direction, so that r becomes x. So now we have x squared dx. And our limits, since we're calculating it from the center of mass, we can go from negative L over 2 to plus L over 2. Okay, the center of mass is our zero position, in other words. So evaluating this integral, straightforward, we have x cubed over 3, evaluated from minus L over 2 to L over 2, or the other way around, rather. And plugging those limits in, we have L cubed over 3 times 6. 2 times 2, nope, I was totally wrong on there. That should be 2 cubed is 8. Minus, let's see, plugging in minus L over 2 cubed gives us negative L cubed over 8 with the 3 out front. Let me write it like that. Now simplifying, we have lambda times L cubed over 24 plus L cubed over 24, right? This is simply lambda equals, what's that, 2 over 24 or 1/12? And now we can plug in for what lambda is. Lambda is simply mass per unit length. Which gives us our final expression of ml squared over 12. This is the moment of inertia expression for a rigid rod as calculated from the center of mass, at the center.